Hello and welcome to Nighttime Science. It's nice to have you here. Maybe today felt long, or maybe you're someone who finds it easier to drift off while thinking about faraway worlds, slow-moving moons, and quiet corners of space, rather than counting sheep. Either way, you're in the right place. For now, there's nothing you need to do. Just rest. Let your breathing slow down. Let your thoughts soften a little. Imagine your body growing lighter, as if gravity itself has relaxed, and you've begun to float calmly, effortlessly, into the dark. Tonight, we're going to wander through the solar system, not in straight lines or strict paths, but in gentle curves and wide, unhurried spirals. We'll pass glowing planets, faint rings made of dust, shadowed craters, and oceans hidden beneath thick layers of ice. This isn't a journey told through equations or charts. It's told through shifting magnetic storms, tilted worlds, and moons that quietly glow against the dark. From planets that spin sideways to storms colder than imagination, every orbit holds something a little strange and quietly beautiful. We'll take it slowly, one soft fact at a time. And before we begin, if these calm explorations help you unwind or give you a peaceful way to end your day, you can gently tap the like button or subscribe. It helps other curious, sleepy minds find their way here too. Now let's begin. Neptune is a world of wind, and not gentle breezes either, even though it lies farther from the sun than any other known planet. Neptune has the fastest winds in the entire solar system. High in its atmosphere, winds can race at speeds over 2,000 kilometers per hour. That's faster than the speed of sound on Earth, faster than a jet flying at full throttle. These powerful winds are thought to be fueled by Neptune's internal heat, which continues to rise outward from the planet's interior. Despite the extreme cold at its surface, its atmosphere, made mostly of hydrogen, helium, and methane, becomes a canvas for massive storm systems, carved and reshaped by constant motion. It's a frozen world, never truly still, always moving, always rushing. Mars, by contrast, holds a wound that seems almost silent, stretching more than 4,000 kilometers across the planet's surface, is Valles Marineris, the largest canyon system in the solar system. It runs along Mars' equator and would span the entire width of the continental United States. In some places, the canyon drops more than 7 kilometers deep. That's over 5 times deeper than the Grand Canyon on Earth. Scientists believe it formed not from flowing rivers, but from immense forces beneath the planet's crust. Tectonic stretching, volcanic activity, and slow erosion may have pulled the surface apart, opening vast cracks that never closed again. It's a scar etched into the face of Mars, a quiet reminder of a violent geological past, now locked in stillness. Venus tells a different story. Despite being remarkably similar to Earth in size and mass, Venus lacks something essential: a global magnetic field. On Earth, this invisible shield is created by the motion of molten iron deep within the planet's outer core. It protects us from solar radiation and helps preserve our atmosphere. Venus appears to be different. Its core may rotate too slowly, or may even be partially solid, preventing the dynamo effect needed to generate a magnetic field. Without this protection, the planet is exposed directly to the solar wind. Over time, lighter elements in Venus's atmosphere were stripped away. What remained became dense, thick, and dangerously hot. The absence of a magnetic field helps explain how a planet that may once have resembled Earth transformed into a world of crushing pressure and endless heat. And farther out, in the cold darkness beyond Saturn, something even more unusual may be happening. On Uranus and Neptune, scientists believe diamonds could actually fall from the sky. Under immense pressure, methane deep within these planets may break apart, allowing carbon atoms to compress and crystallize. The result could be diamond rain, slowly sinking through layers of ice and liquid, glittering silently as it falls. No sound, no light, just time, pressure, and unimaginable cold. And this is only the beginning. Ashjitametni, Bildalari Korherek, Telef Riski Alashtermiakek Shekelda, Insan Yazami Hisivaran, Sleep Friendly V Yavish, Tempelu Bur Anlatimla, Yeniden Yazdam, Tun V Riddim Ernseki Metanol by Rebir Iamlu, Arkaplanda Sorensuska, Burlish Tyrebelerson. Deep inside the atmospheres of Uranus and Neptune, the conditions become almost unimaginable. Cold, darkness, and pressure layered on top of one another. These distant ice giants are rich in methane gas, and far below their visible clouds, the pressure and heat may be intense enough to pull methane apart, piece by piece. When that happens, carbon atoms are released. Over time, those carbon atoms can compress, slowly, silently, until they lock into crystalline forms, tiny diamonds. Laboratory experiments on Earth have recreated parts of this process, showing that under the right conditions, hydrocarbons can indeed transform into diamond. If the theory holds true, then somewhere deep within these planets, storms of glittering crystals may be drifting downward, falling through layers of blue darkness toward the core. No light, no sound, just diamonds quietly raining in the cold. Earth, meanwhile, has something no other known planet does. Plate tectonics. Beneath our feet, Earth's crust is broken into massive plates that slowly glide atop the softer mantle below. These plates collide, pull apart, and slide past one another, shaping the planet over immense stretches of time. They build mountains, they trigger earthquakes, they recycle carbon dioxide, helping regulate the climate across millions of years. So far, no other planet shows clear evidence of this kind of global system. Mars and Venus bear cracks, volcanoes, and ancient scars. but they appear mostly still by comparison. Their surfaces tell stories of activity long ago, now quiet and unmoving. Earth's shifting plates may be one of the reasons life has been able to persist here. A slow, steady cycle that stabilizes temperature, sustains oceans, and allows continents to wander across the planet over eons. Even asteroids, small as they are, can surprise us. We often imagine them as lonely travelers, drifting silently through space. But some asteroids have companions, tiny moons orbiting around them. These miniature satellites may be captured fragments or pieces that formed alongside their parent asteroid. The first asteroid moon ever discovered was Dactyl, found orbiting the asteroid Ida by the Galileo spacecraft in 1993. Since then, astronomers have identified dozens of similar systems. Some asteroids even exist in binary pairs, where two bodies circle one another in a delicate gravitational balance. They're reminders that gravity doesn't need something large to work. Even the smallest objects can be linked together, drifting quietly through space as partners. Mercury offers another kind of contrast. Unlike Earth, it doesn't have a true atmosphere. There's no thick blanket of gas to trap heat or scatter sunlight. Instead, Mercury is surrounded by something much thinner, an exosphere. It's a near vacuum, made of individual atoms that rarely collide with one another. These particles come from Mercury's surface itself, blasted free by solar wind and constant micrometeoroid impacts. Sodium, potassium, oxygen, because Mercury's gravity is too weak to hold them for long. These atoms escape into space and are continually replaced by new ones from below. The result is a faint, ghostly envelope, invisible to the eye, but detectable with sensitive instruments. And at the center of it all, the sun quietly gives itself away. Every second, more than 4 million tons of the sun's mass are converted into energy. Deep in its core, hydrogen atoms fuse into helium, releasing light and heat that flood the solar system. That energy warms planets, drives winds, sustains life on Earth. The loss is tiny compared to the sun's total mass, almost insignificant moment to moment. But over billions of years, it accumulates. One day, the sun will change as its fuel runs low. But for now, it burns steadily, sacrificing a small part of itself with every passing second. And circling farther out, another slow change is already underway. Saturn's rings are quietly disappearing. Albet, Ashjida-Metni Bilgelari Korarak, Erskun, Insan Yazami Hisivaran, Sleep Friendly, Yavash Tempelu V Hike, Akishli Bur, Dil Yeniden Yastam, Ernseki Burlumlurl Tun V Riddim Tamamen Iamlu. The graceful rings that circle Saturn may look eternal, but they are not meant to last forever. Very slowly, almost imperceptibly, they are falling inward, pulled by Saturn's gravity and guided by its magnetic field. tiny streams of icy particles drift down toward the planet. This gentle process is known as ring rain, not a sudden collapse, but a quiet, continuous descent. Data from the Cassini spacecraft suggests that Saturn's rings may be surprisingly young, possibly less than 100 million years old, and over the next few 100 million years, they could fade away entirely. They feel timeless when we look at them, but they are temporary, a shimmering moment in Saturn's long history, slowly dissolving back into the planet that created them. Mars, on the other hand, is anything but still. The red planet is famous for its vast deserts and rusty surface, but also for dust storms, unlike anything on Earth. At times, these storms grow so large they wrap around the entire planet. They can last for weeks, sometimes even months. The dust is extremely fine, light enough to remain suspended in the air, turning the sky into a hazy red veil and blocking much of the sunlight below. Some storms begin quietly, as small gusts of wind, but grow rapidly through feedback between heat, atmospheric circulation, and the planet's surface. In 2018, one such storm brought an end to the Opportunity rover's long mission. As dust covered its solar panels and cut off its power, even without oceans or rain, Mars remains restless, a world that still moves, still shifts, still changes. Far beyond Mars, one of Jupiter's moons hides something extraordinary. Beneath the fractured ice shell of Europa, there is strong evidence for a vast ocean of liquid water. Jupiter's immense gravity flexes the moon's interior as it orbits, generating heat through tidal forces. That heat may be enough to keep the ocean from freezing solid. Europa's surface is etched with dark lines and ridges, signs that the ice above may be slowly shifting and cracking. Spacecraft have detected magnetic signals and chemical clues that support the idea of a salty, conductive ocean below. What makes Europa especially intriguing is possibility. A dark ocean sealed beneath ice, warmed from below, potentially rich with the basic ingredients needed for life. Mars holds another silent giant, rising nearly 22 kilometers above the surrounding plains. Olympus Mons is the tallest volcano in the solar system, almost 3 times the height of Mount Everest, so wide it could cover an entire US state. It formed through repeated volcanic eruptions over millions of years, and it grew so large because Mars lacks plate tectonics. On Earth, shifting plates carry volcanoes away from their magma sources, forming chains like the Hawaiian Islands. On Mars, the crust stayed still. The magma rose in the same place, again and again, until a single colossal volcano stood alone, looming quietly beneath the Martian sky. Saturn's rings, for all their size, are astonishingly thin. They stretch more than 280,000 kilometers across. Yet, in most places, they are less than 100 meters thick, thinner than many buildings on Earth. made mostly of water ice. The particles range from tiny grains to boulders the size of houses. When sunlight strikes them edge-on, the rings nearly vanish, like a sheet of glass turned sideways. Their delicate flatness is maintained by Saturn's gravity. The subtle interactions between billions of icy fragments and the steady guidance of small shepherd moons. From afar, they seem solid and bold. Up close, they are fragile, ethereal, and finally, there is Earth. Among all the planets in the solar system, Earth is the densest. It packs more mass into each cubic kilometer than any other planet. This density comes from its structure, a metal-rich core wrapped in a rocky silicate mantle, layer upon layer, compressed by gravity, balanced just right. It's another quiet detail, one more subtle reason Earth is the way it is. Ashjida metni, Bildleri by Reber Korherak, Erskun, Insan Yazami Hisiverin, sleep-friendly, Yavash Tempelu V Hike, Akishli Bur, Dil Yeniden Yazdam. Ernseki Burlumlol Riddim, Vitun, Tamimen, Iam Luger, Nighttime Science Anlatimina, Dogrudin Eklinebelir. Earth is dense, denser than it looks. On average, Earth's density is about 5.5 grams per cubic centimeter. That's higher than even Jupiter's, despite the gas giant's enormous size. This compact heaviness matters. Deep inside Earth, molten iron slowly moves within the outer core. That motion generates the magnetic field that surrounds our planet, quietly deflecting radiation and shielding the surface from the harshness of space. Layer by layer, Earth is built to be solid and concentrated. Its density shapes its gravity, its geology, and the invisible protection that makes life possible here. The sun, meanwhile, is never truly still. Although we can't hear it, the sun vibrates constantly. Pressure waves ripple through its blazing interior, rising and falling as currents of plasma move beneath the surface. These oscillations produce ultra-low frequency sounds, far below the range of human hearing. Scientists study them through a technique known as heliosseismology. By tracking how these waves travel and reflect inside the sun, researchers can map its hidden structure. Much like seismic waves reveal the interior of Earth. Through these subtle vibrations, scientists uncover deep flows, magnetic activity, and the dynamics of fusion at the core. In a quiet way, the sun is always humming, a steady rhythm, carrying secrets through motion and sound. Venus moves to a different beat. Unlike most planets, Venus rotates backward, a motion known as retrograde rotation. On its surface, the sun would rise in the west and set in the east. Even more unusual, Venus turns incredibly slowly. One full rotation takes 243 Earth days, longer than a year on Venus itself. The reason remains uncertain. One theory suggests a massive collision early in Venus's history, enough to disrupt and reverse its spin. Another proposes that long-term tidal interactions with the sun gradually altered its rotation. Whatever the cause, Venus remains an outlier, a slow-turning world with a reversed rhythm. Jupiter is a world of company. The largest planet in the solar system also holds the largest family. Astronomers have identified more than 90 moons orbiting Jupiter, and new ones continue to be discovered. The four largest, Io, Europa, Ganymede, and Callisto, are known as the Galilean moons. First observed by Galileo Galilei in 1610, each is a world of its own. Beyond them lies a swarm of smaller, irregular moons. Many were likely captured from passing objects. Some orbit in reverse. Others are only a few kilometers wide. Together, they form a miniature solar system, bound by Jupiter's immense gravity and shaped by its long history. Mercury hides something unexpected. By day it scorches, by night it freezes, and yet at its poles, deep inside craters that never see sunlight, water ice survives. These permanently shadowed regions remain cold enough to preserve ice for millions of years. Spacecraft such as Messenger detected bright radar reflections from these areas, confirming the presence of frozen water. Scientists believe the ice may have arrived through comet impacts or ancient volcanic outgassing. In the heart of one of the hottest planets, ice endures, locked in darkness, protected by shadow, and far beyond, on the edge of the solar system, Pluto may be hiding more than it reveals. The bright, heart-shaped region known as Sputnik Planitia is more than a striking feature. Beneath it, there may be a subsurface ocean, buried deep below layers of ice, a quiet reservoir hidden from view, waiting far from the sun in the cold. Ashtidametni Bilgelari Korerak, Tamimen Erskun, Insan Yazami Hisivaran, sleep-friendly, Yavash Tempeluvi, Akisai Bur Dil Yeniden Yazdam. Ernseki Nighttime Science Burlum Laurel Riddim Vitun by Rebir Iam Ludyr. Pluto is distant, so distant that sunlight there feels more like a memory than a presence, cold enough to freeze even nitrogen. And yet, beneath its icy surface, something warmer may be hiding. Data from the New Horizons spacecraft suggests that below Pluto's crust, a layer of liquid water could still exist. The sheer weight of the large basin known as Sputnik Planitia, along with signs of subtle geological movement, points toward a softer, slowly shifting interior. If such an ocean is there, it may be kept from freezing by heat released through radioactive decay. Trapped beneath thick, insulating layers of ice above, even at the edge of the solar system, far beyond Neptune, a hidden sea may quietly endure, unseen, unmoving, but not gone. The asteroid belt, despite how it's often imagined, is mostly empty. It doesn't resemble a chaotic minefield filled with tumbling rocks. In reality, the region between Mars and Jupiter is vast, and the asteroids within it are spread far apart. Millions of rocky bodies do orbit there, but the distances between them are enormous. A spacecraft passing through would be very unlikely to encounter anything at all. Even taken together, the entire mass of the asteroid belt amounts to less than 5% of the moon's mass. A few large objects, such as Ceres and Vesta, account for most of it. The rest are fragments, leftovers from the early solar system, ancient building blocks that never came together to form a planet. Uranus moves in a way no other planet does. Most planets spin like gently tilted tops. Uranus, however, is tipped almost completely on its side, with an axial tilt of about 98 degrees. As it travels around the sun, it doesn't just spin, it rolls. This extreme tilt creates seasons unlike anything else in the solar system. Each pole experiences about 42 years of continuous daylight, followed by 42 years of darkness. Why Uranus ended up this way is still debated. It may have been struck by a massive object long ago, knocking it sideways, or a series of interactions slowly tipped it over. Whatever the cause, Uranus remains a world with one of the strangest climates ever discovered. Jupiter, for all its beauty, hides invisible danger. The planet is wrapped in the most powerful magnetic field of any planet in the solar system. Within it lie radiation belts so intense they would quickly disable or destroy unprotected spacecraft. These belts are filled with high-energy charged particles trapped by Jupiter's magnetic field. They resemble Earth's Van Allen belts, but on a far more extreme scale. Even Jupiter's moons are affected by this radiation, shaping their surfaces and influencing their potential to support life. Any spacecraft venturing close must be carefully shielded or guided through safer paths. Jupiter is magnificent, but it is also unforgiving. At the center of everything, the sun holds nearly all that exists here. More than 99.8% of the solar system's total mass belongs to the sun alone. All the planets, moons, asteroids, comets, and dust combined make up less than a fraction of what remains. This immense mass is what binds everything in orbit, from tiny particles drifting in the asteroid belt to distant comets far beyond Pluto. It's also what fuels the sun's core. The pressure and gravity allow hydrogen to fuse into helium, releasing the energy that fills the solar system with light and warmth. Beyond Neptune, the story continues. Out there, scattered through the Kuiper belt and farther still, are countless icy worlds. Many are large enough to be round, yet not dominant enough to clear their orbits. These are dwarf planets. Pluto is the most familiar, but it's only one among many. Others, such as Eris, Haumea, and Makemake, share this category, and new candidates are still being found. In fact, dwarf planets may outnumber the 8 classical planets by a wide margin. They are ancient worlds, small, cold, and largely untouched, quiet relics from the earliest days of the solar system. Ashigitametni Bilgelary Digistermedin, Erskine, Insan Yazami Hisivaran, Sleep Friendly, Yavashvi Hike, Akishli Burr, Dil Yeniden Yazdam. Ernseki Nighttime Science, Burlum Laurel Tun V Tempo, by Rebir Iam Ludur. Though they drift in the cold and distant shadows, these small worlds carry clues about how everything we know first came together. Venus, for example, moves through time very differently. A single day on Venus lasts longer than an entire year. The planet turns so slowly that it takes 243 Earth days to complete one full rotation. Yet it only needs 225 days to orbit the sun. So from one sunrise to the next, more than a year has already passed. This sluggish rotation plays a role in Venus's extreme conditions. Heat builds and lingers. Surface temperatures climb high enough to melt lead. Wrapped in a thick, acidic atmosphere and crushed under immense pressure, Venus becomes a world of slow motion. Long days, blinding heat, an eerie place where time itself seems stretched. Farther out, Saturn's moon Titan offers a different kind of familiarity. Titan is the only other place in the solar system known to have stable liquids on its surface. But these liquids are not water. Instead, lakes and rivers of liquid methane and ethane flow across its surface, carving shorelines shaped by cold chemistry. Its thick, nitrogen-rich atmosphere supports weather systems, including methane rain and seasonal storms. Some of Titan's lakes are enormous, stretching hundreds of kilometers across, and beneath its icy crust, scientists believe a hidden ocean of water may exist as well. Titan feels strangely recognizable. Clouds, rivers, coasts, all built from substances that don't belong to Earth. Mars has companions of its own, though they are small and irregular. Phobos and Deimos, the two moons of Mars, look more like captured rocks than traditional moons. They are misshapen, cratered, and uneven. Many scientists think they were once asteroids, pulled from the asteroid belt long ago and trapped by Mars's gravity. Their low density and unusual orbits support this idea, though some theories suggest they may have formed from debris after a massive impact. Phobos is slowly spiraling inward and will eventually break apart or collide with Mars. Deimos, meanwhile, is drifting farther away, quiet passengers in orbit, leftovers from a turbulent past. Jupiter, by contrast, radiates power from within. Unlike most planets, Jupiter emits more energy than it receives from the sun. This internal heat comes from the planet's formation, energy released as its immense mass collapsed under gravity. Even now, Jupiter continues to contract slightly, generating heat as it does. That warmth fuels its violent weather, the swirling bands, and the giant storms that never seem to fade. In infrared light, Jupiter glows like a smoldering ember beneath its clouds. It isn't a star, but it came close. With just a little more mass, Jupiter might have ignited nuclear fusion and become a failed sun. And finally, there is Neptune, a planet found not by sight, but by thought. Before Neptune was ever seen, astronomers noticed something strange. Uranus's orbit didn't behave exactly as expected. Tiny deviations hinted at an unseen influence. In the 1840s, two mathematicians, working independently, calculated where a hidden planet must be to cause those disturbances. They followed the numbers, the gravity, the maths. When telescopes were pointed toward the predicted location, Neptune was there, a quiet victory for human curiosity, proof that even invisible worlds can be discovered through patience, patterns, and careful reasoning. Ashjidametni, Bildleri Korerak, Tamimen Erskun, Insan Yazami Hisiverin, Sleep Friendly, Yavash Tempeluvi Hike, Akishli Burr, Dil Yeniden Yazdam. Ernseki Nighttime Science, Burlum Laurel Riddim, Vitun, by Rebir Iam Lujer. Neptune holds a quiet distinction. It was the first planet discovered on paper before it was ever seen through glass, a world revealed by equations and careful calculation, long before a telescope confirmed its presence. Numbers pointed the way, and space followed. High above Saturn's North Pole, something unexpected turns. A massive cloud formation spins there in the shape of a near-perfect hexagon. 6 clean sides, sharp angles, stretching more than 30,000 kilometers across, wider than Earth itself. This strange jet stream has persisted for decades, perhaps even centuries. Scientists believe it forms from the way Saturn's atmosphere rotates, interacting with stable waves of air locked around the pole. In laboratory experiments, similar shapes appear when fluids rotate at different speeds. Still, seeing such precise geometry emerge naturally in a planetary sky feels almost unreal, elegant, surreal, as if order briefly revealed itself in motion. The sun, too, hides a quiet paradox. You might expect its surface to be the hottest place of all, but it is. The visible surface, known as the photosphere, reaches temperatures of around 5,500 degrees. Above it lies the corona, the sun's outer atmosphere, where temperatures soar past 1 million degrees. This dramatic rise has puzzled scientists for decades. One idea suggests that magnetic waves carry energy upward from deep within the sun. Another points to countless tiny eruptions, called nanoflares, releasing bursts of heat. However it happens, the result is the same. The sun's outer layers burn hotter than the surface below, glowing with heat that seems to defy intuition. Beyond Neptune, the solar system grows quieter and colder. There, a vast region known as the Kuiper Belt stretches outward for billions of kilometers. It is filled with icy worlds, frozen remnants left behind from the solar system's earliest days. Pluto lives there, along with Eris, Haumea, and Makemake. Some are round enough to be classified as dwarf planets. Others are irregular, tumbling silently through space. The Kuiper belt resembles the asteroid belt in structure, but it is far colder, richer in primordial ice, a fossil zone, a frozen archive of the material that built the outer planets. And beyond even that, the solar system may fade into a final halo. Far past the Kuiper belt lies the hypothetical Oort cloud, never directly observed, but strongly suspected, a vast, spherical shell of icy debris that may extend nearly a light year from the sun. This distant cloud is thought to be the source of long-period comets, objects that appear suddenly from deep space on unpredictable paths. They are only weakly bound to the sun. A passing star or a gentle tug from the galaxy itself could send one falling inward. If the Oort cloud exists, it marks the true edge of the sun's gravitational reach, a final boundary, a quiet, frozen frontier. Closer in, Jupiter's moon Io refuses to be calm. Io is the most volcanic world in the solar system. Its surface is alive with constant eruptions, reshaped again and again by molten rock and sulfur. Volcanic plumes rise hundreds of kilometers into space, painting the landscape in vivid yellows, reds, and blacks. Nothing there stays the same for long. This relentless activity is powered by tidal heating. Jupiter's immense gravity squeezes and stretches Io as it orbits, along with subtle tugs from neighboring moons. The constant flexing generates friction, and friction creates heat. Unlike Earth's slowly cooling crust, Io remains young, unstable, and ever-changing. A lava-lit moon with a restless, molten heart, and orbiting Neptune. One final oddity moves against the flow. Triton, Neptune's largest moon, travels backward around its planet, a retrograde orbit, opposite to the direction Neptune spins. This unusual motion suggests Triton was not born there. It was likely captured long ago, pulled in by gravity and forced into a reversed path. A moon moving the wrong way. A reminder that not everything forms neatly. Some worlds arrive from elsewhere. Ashjida Metni Biljalari Korerak, Erskun, Insan Yazami Hisivaran, Sleep Friendly, Yavash Tempeluvi Hike, Akishli Burr, Dil Yeniden Yazdam. Ernseki Nighttime, Science, Burlum Laurel Riddim, Vitun, Tamamen, Iam Ludur. This backward journey tells an important story. Triton likely did not form beside Neptune at all. Instead, it was probably captured long ago from the Kuiper belt. That capture may have caused chaos, disturbing, or even destroying Neptune's original system of moons. Despite its distance and cold, Triton is far from quiet. It shows signs of geological activity, including cryovolcanoes that erupt icy material into space. It also has a thin atmosphere, one that appears and fades with the seasons. Cold, distant, moving in reverse. Triton is a world that challenges expectations at every turn. Earth's moon holds a quiet distinction of its own. compared to the planet it orbits. Our moon is unusually large. No other rocky planet in the solar system has a satellite so big in proportion. The moon is about 1/4 the diameter of Earth, a ratio more commonly seen in dwarf planet systems than full-sized planets. Most scientists believe it formed after a colossal impact, when a Mars-sized body collided with the young Earth. The debris from that collision spread into orbit, slowly gathering into the moon we see today. This close relationship has shaped Earth ever since, influencing tides, stabilizing climate, and guiding the rhythm of oceans for billions of years. The moon is more than a companion. It is the lasting imprint of destruction, followed by renewal. The paths planets follow are quieter than we imagine, but not perfect, though we often picture planets tracing flawless circles around the sun. Their orbits are actually ellipses, gently stretched paths, with the sun resting slightly off-center. Each planet has a closest point to the sun, called perihelion, and a farthest point, known as aphelion. For most worlds, the difference is subtle. For others, like Mercury and Pluto, it is far more pronounced. These variations affect how fast planets move, how much sunlight they receive, and how seasons unfold. This elegant truth was first described by Johannes Kepler in the early 1600s, reshaping how we understand motion in the solar system. Even the smallest deviations matter. Some visitors arrive from the very edge. Long-period comets, the kind that return only once every few thousand years, are thought to originate in the Oort cloud, a distant, icy shell that may stretch nearly a light year from the sun. These comets travel along vast, elongated paths, loosely bound by gravity. A passing star or a subtle tug from the galaxy itself can dislodge them, sending them inward. When they approach the sun, they bloom into glowing tails, briefly visible from Earth. Many may have drifted in darkness for billions of years before that moment. Their appearance is fleeting, but they carry some of the oldest, most untouched material in the solar system. The sun, too, has a future written into its light. Like all stars, it will not burn forever. In about 5 billion years, the sun will exhaust the hydrogen fuel at its core and begin to expand. It will swell into a red giant, likely engulfing the inner planets. Later, it will shed its outer layers, forming a glowing planetary nebula. What remains will be a white dwarf, a dense, Earth-sized core made mostly of carbon and oxygen. It will no longer create energy. Instead, it will slowly cool, fatting over trillions of years, a quiet ember left behind in the dark, the final chapter of the sun's long journey. Mars, meanwhile, shares something familiar with Earth. Despite its thin atmosphere and colder climate, Mars experiences seasons much like our own. Its axis is tilted, just enough to create changing patterns of sunlight as it orbits the sun. Polar ice grows and shrinks. Winds shift. The planet breathes in its own way. Even worlds that seem distant and barren still move to rhythms we recognize. Ashjidametni Biljulari Korerak, Erskun, Insan Yazami Hisivaran, Sleep Friendly, Yavash Tempeluvi Hike, Akishli Burr, Dil Yeniden Yazdam. Ernseki Nighttime Science Burlum Laurel Tun, V Riddim Tamamen Iam Ludur. Mars has seasons for a familiar reason. Its axis is tilted by about 25 degrees, very close to Earth's tilt of 23 degrees. As Mars travels around the Sun, this tilt causes sunlight to favor one hemisphere, then the other, over the course of the year. The result is a slow cycle of spring, summer, autumn, and winter. Temperatures rise and fall. Light shifts gently across the surface. These seasonal changes influence the polar ice caps, the movement of dust storms, and even subtle variations in air pressure. Everything unfolds more slowly than on Earth, though, because a year on Mars lasts nearly twice as long. Time stretches there, but the rhythm remains. Among all the moons in the solar system, one stands above the rest. Ganymede, a moon of Jupiter, is the largest natural satellite we know. It is even bigger than the planet Mercury, with a diameter of more than 5,000 kilometers. Ganymede has a rocky core, a thick icy crust, and strong evidence for a hidden ocean beneath its surface. Ancient ridges and scars mark its frozen exterior, telling a story written long ago. Ganymede is also unique in another way. It is the only moon known to generate its own magnetic field. That field creates faint auroras that shimmer in its thin atmosphere. Scientists believe Ganymede may contain multiple layers of liquid water, trapped between sheets of ice, forming a complex and layered interior. Despite its size and richness, it remains quiet, dark, orbiting deep within Jupiter's powerful magnetic embrace. Pluto, distant and small, sometimes breaks expectations. Although it is usually the farthest of the known planets or dwarf planets, Pluto follows a highly elliptical path. At times, that path brings it closer to the Sun than Neptune. This happened between 1979 and 1999, when Pluto briefly became the 8th planet from the Sun. Even then, the two worlds never collided or came dangerously close. Their orbits are locked in resonance. For every 3 orbits Neptune completes, Pluto finishes exactly 2. This gravitational rhythm keeps their paths safely aligned, never crossing. A delicate celestial dance, guided by time and motion. The Sun, too, moves through cycles. About every 11 Earth years, the Sun's magnetic field reverses itself. The north and south magnetic poles quietly switch places. This process, known as the solar magnetic cycle, is tied to the Sun's internal dynamics. It influences sunspots, solar flares, and powerful bursts of energy known as coronal mass ejections. During solar maximum, activity increases. The Sun becomes restless, radiating more energy and stirring magnetic storms. As the cycle fades towards solar minimum, it grows calmer again. These changes reach Earth, shaping auroras, affecting satellites, and subtly influencing the upper atmosphere. The sun's magnetism is not fixed. It rises and falls like a slow, breathing heartbeat. Some fears, however, don't hold up to the calm of science. Planetary alignments are often blamed for earthquakes or disasters on Earth, but there is no evidence that they cause such events. The gravitational pull of distant planets is incredibly weak compared to the influence of the moon or the sun. Even during rare alignments, their combined effect is negligible. The moon, close and constant, shapes tides and stresses Earth's crust far more than massive planets like Jupiter or Saturn ever could. Alignments are beautiful, mathematically elegant, but harmless, a silent dance, not an omen. Leaving the solar system, on the other hand, is no simple journey. Escaping the sun's gravitational grip takes time, a great deal of it. Spacecraft like Voyager 1 and Voyager 2, launched in the 1970s, spent decades traveling outward. Only recently did they cross into interstellar space, beyond the heliosphere, where the sun's influence fades into the wider galaxy. Even then, they continue to move slowly, carrying quiet messages from Earth into the dark between the stars. Ashajida metniyin bilgelari kor erak, Erskun, insan yazami hisiverin, sleep friendly, Yavash Tempeluvi, Akisai Bur Dil Yeniden Yastim. Nighttime Science Anlatimula by Rebir Ayam Ludyr. These journeys took time, a great deal of it. The Voyager missions needed more than 40 years to reach that distant boundary, traveling outward at speeds exceeding 60,000 kilometers per hour. They crossed the paths of the planets, slipped past the Kuiper belt, and continued onward into the dark. Even now, their instruments still function, and tucked safely on board is a golden record, carrying sounds, music, and voices from Earth. They move silently, steadily, are quiet ambassadors, drifting into the wider galaxy. Back home, Earth is quietly protected. Surrounding our planet is an invisible magnetic field, created by the slow movement of molten iron deep within Earth's outer core. This field bends and deflects charged particles streaming from the sun, shielding the atmosphere and the surface below from harmful radiation. Without this protection, the solar wind would gradually strip our atmosphere away, much as it likely did on Mars long ago. Some particles are guided instead toward Earth's poles, where they collide with atmospheric gases and create auroras. Green, red, violet, shimmering curtains of light that dance across the sky. Earth's magnetosphere is not static. It shifts and breathes, a living shield that has preserved both climate and life over immense spans of time. The moon, meanwhile, is slowly drifting away. Each year, it moves about 3.8 centimeters farther from Earth. This gentle retreat is driven by tidal interactions. As Earth's gravity pulls on the moon, it raises bulges in our oceans. Those bulges, in turn, transfer energy, pushing the moon outward ever so slightly. Long ago, the moon was much closer, larger in the sky, more dominant. As it continues to recede, Earth's days slowly lengthen, and eclipses grow rarer and less dramatic. Billions of years from now, total solar eclipses will no longer be possible at all. The sky is changing, quietly, even if we don't yet feel it. Far beyond Neptune, the Kuiper Belt holds worlds that shine unexpectedly. Among its icy inhabitants are objects with remarkably bright, reflective surfaces. Some are coated in crystalline water ice, polished by ancient processes. Haumea, for example, spins rapidly and has an elongated, almost football-like shape, its surface gleaming in the cold. Eris reflects so much sunlight that it appears brighter than freshly fallen snow. These surfaces may have been renewed by cryovolcanism, impacts, or chemical reactions over time. In the deep darkness at the edge of the sun's reach, some of these distant worlds gleam like mirrors, catching faint light, holding it briefly, then letting it go. Closer to Saturn, a small moon makes a bold statement. Enceladus may be tiny, but it is astonishingly active. From fractures near its south pole, known as tiger stripes, powerful geysers erupt into space. Plumes of water vapor and ice crystals rise high above the surface, driven by tidal heating below. Saturn's gravity flexes the moon's interior, generating enough heat to keep a hidden ocean liquid. The material carried in these plumes contains salts, organic compounds, and signs of hydrothermal activity, clues that hint quietly at the possibility of life. Some of this water escapes entirely, feeding Saturn's E-ring, a living exchange between moon and planet. And finally, not all asteroids are what they seem. Many are not solid chunks of rock at all. Instead, they are loose collections of stones, gravel, and dust, held together only by gravity. These so-called rubble piles often form after violent collisions, shatter larger bodies. Over time, the fragments drift back together, assembling into fragile shapes. They are delicate, easily disturbed, remnants of ancient impacts that never fully healed. Ashjida metniyin bilgeleri korerak, Erskun, insan yazami hisiverin, sleep-friendly, Yavashvi, akisibur anlatimla, yeniden yazdum. Ernseki nighttime, science, burlumlarel tanuvi ritmi, by Rebir Iam Lujer. Rubble pile asteroids are fragile things. Inside them, there can be large, empty spaces, voids where nothing fills the gaps between rock and dust. They often spin in unexpected ways, wobbling slightly as they travel, and they can subtly change shape when stressed. Missions like Hayabusa 2 and OSIRIS-RX have visited these bodies up close. What they found confirmed the suspicion. These asteroids are porous, delicate. They are not solid relics carved from a single piece of stone. They are loose gatherings, chaotic assemblies of debris, barely holding together as they circle the sun. Ancient ruins drifting quietly through space. Mercury tells a different kind of story. It is a small planet, yet its heart is immense. An unusually large iron core makes up nearly 80% of Mercury's radius, far more than what we see in Earth or Venus. Why this core is so oversized remains uncertain. Some scientists think Mercury once had a much thicker rocky mantle, stripped away by a colossal impact early in its history. Others suggest it formed close to the sun, where intense heat and solar forces favored the gathering of heavier elements. Whatever the reason, the result is striking. A planet with a thin crust, a massive metallic center, and a weak magnetic field. A dense survivor from the solar system's turbulent youth. Venus, meanwhile, travels alone. Among the rocky planets, only Mercury and Venus have no moons at all. Mercury's closeness to the sun offers a possible explanation. Venus's emptiness is harder to understand. It is similar in size to Earth, yet it has no lunar companion. Some theories suggest Venus once had a moon that eventually fell back into the planet, or was lost in a violent collision. Others propose that Venus's slow, backward rotation makes stable moon orbits difficult to maintain. Whatever the cause, Venus circles the sun by itself, a bright world wrapped in clouds, its skies forever empty of moons. Most moons in the solar system belong elsewhere. The giant planets of the outer solar system are surrounded by sprawling families of satellites. Jupiter and Saturn each host dozens of confirmed moons, ranging from tiny captured rocks to massive worlds like Ganymede and Titan. Uranus and Neptune also hold collections of icy moons, some with unusual orbits and hidden oceans beneath their surfaces. Together, these planets act like miniature solar systems, their gravity gathering debris and shaping it into companions over time. The farther from the sun you travel, the more moons you tend to find. A quiet reminder that gravity gathers company most easily in the cold. Even from close to home, we can see far. Orbiting just above Earth, the Hubble Space Telescope has captured remarkably detailed images of distant planets, cloud bands on Jupiter, towering storms on Neptune, subtle seasonal changes unfolding on Mars. These observations stretch across years and decades, filling the gaps between brief spacecraft visits. Hubble allows scientists to watch weather evolve, track storms, study rings, and observe planetary auroras in ultraviolet and visible light. From its silent path around Earth, Hubble watches not only distant galaxies, but the familiar faces of our neighboring worlds as they slowly change. And on Jupiter, one storm refuses to fade. The Great Red Spot is a vast vortex swirling in the planet's southern hemisphere, large enough to swallow 2, perhaps even 3 Earths. It has raged for at least 350 years, and possibly much longer. First seen through early telescopes in the 17th century, the storm has changed shape over time, gradually shrinking. Yet it remains powerful, persistent, a reminder that on Jupiter, time moves differently, and storms can last for centuries. Ashigita metni yain bilgelari kor erak, Erskun, insan yazami hisiverin, sleep-friendly, Yavesh vi akisai bur dil yeniden yazdam. Nighttime Science and Latimula by Rebir Ayam Lujer. The great red spot wears its color like a quiet signature. That deep reddish tone may come from complex chemical reactions high in Jupiter's atmosphere, shaped by sunlight and unusual compounds at great altitude. Along the storm's outer edges, winds race at speeds exceeding 400 kilometers per hour. On Earth, storms arrive and fade within days or weeks. This one has endured for centuries, caught within Jupiter's turbulent cloud bands, turning endlessly, season after season, far away from the sun. Neptune tells another energetic story. Despite its distance, Neptune is not a silent, frozen world. It radiates far more energy than it receives from sunlight, about 2.5 times as much. That internal heat fuels powerful storms and drives the fastest winds ever measured in the solar system. Why Neptune remains so warm is still uncertain. It may be releasing leftover heat from its formation. It may be slowly contracting under gravity, or it may be warmed from within by radioactive elements deep in its core. Whatever the source, the result is clear. A planet with a cold surface and a restless interior, constant motion beneath pale blue clouds. Earth holds a rare balance. It is the only planet where water naturally exists in all 3 states at once: solid ice at the poles and in glaciers, liquid water flowing through oceans, rivers, and lakes, water vapor drifting invisibly through the air, gathering into clouds. This balance is not accidental. It depends on Earth's distance from the sun, its atmospheric pressure, and a climate stable enough to let water move freely between states. Other worlds may hold water in fragments, frozen crusts, thin vapor, hidden oceans sealed beneath ice. But only on Earth does water flow, freeze, and rise again in a continuous planet-wide cycle, a quiet dance that sustains life. Far beyond the planets, the sun's influence finally softens. As the solar wind streams outward, it eventually meets the interstellar medium, the sparse gas and dust that fills the space between stars. The boundary where these forces balance is called the heliopause. It marks the outer edge of the heliosphere, the sun's protective bubble. Beyond it, the pressure of the galaxy outweighs the sun's breath. Voyager 1 crossed this boundary in 2012. Voyager 2 followed in 2018. Both entered true interstellar space. Though the sun's gravity reaches much farther, the heliopause marks the end of its energetic reach, the final whisper of solar influence before the deep dark begins. Even now, the solar system is not at rest. We are moving through a region of space known as the local interstellar cloud, a thin veil of gas and dust, roughly 30 light-years across. This cloud is part of a much larger structure called the local bubble, carved long ago by ancient supernova explosions. As the sun travels through it at thousands of kilometers per hour, the heliosphere acts as a shield, deflecting much of the interstellar material. Scientists study this cloud to understand how conditions beyond the solar system affect cosmic rays, the shape of the heliosphere, and even subtle influences on Earth's environment. We are not standing still in space. We are drifting, quietly sailing through a faint galactic fog. And not all movement belongs to planets. Some moons are alive with energy. Io, orbiting Jupiter, is scarred by countless active volcanoes, fueled by tidal forces that need its interior. Enceladus vents towering plumes of water vapor and ice into space as Saturn's gravity flexes its hidden ocean below. Europa and Ganymede, too, may hide vast subsurface seas, kept liquid by internal warmth and constant motion. In the cold reaches of the solar system, even moons can stir, changing slowly, quietly active, worlds within worlds. Ashjada metni yain bilgelari korerak, Erskun, insan yazami hisivaran, sleep-friendly, Yavashvi hike, akishli bur, dil yeniden yazdam. Ernseki nighttime science, Burlum Laurel Tun v Tempo, by Rebir Iam Ludur. Even far from the sun, movement continues. Triton, Neptune's captured moon, shows signs of cryovolcanism, icy eruptions driven not by heat, but by shifting pressures deep below its frozen surface. Material rises, breaks through, then settles again into the cold. These moons are not simple balls of ice. They are active worlds, shaped by geology and chemistry, and perhaps holding conditions that could support biology beneath their shells. Quiet on the outside, restless within, Pluto breathes in its own distant way. Though small and bitterly cold, Pluto carries a thin atmosphere made mostly of nitrogen, with traces of methane and carbon monoxide. As it moves closer to the sun along its elongated orbit, surface ices slowly sublimate. Solid becomes gas. A fragile atmosphere forms. When Pluto drifts farther away again, the cold returns. The atmosphere collapses, freezing back onto the surface like frost settling overnight. This cycle repeats over Pluto's long, 248-year journey around the sun. When New Horizons passed by in 2015, this atmosphere appeared as a delicate, layered blue haze, a brief breath of warmth surrounding a world that spends most of its time in deep cosmic winter. At the center of the sun, conditions are anything but calm. Deep in its core, temperatures rise above 15 million degrees Celsius. There, hydrogen atoms are crushed together by immense pressure until they fuse into helium, releasing vast amounts of energy. This fusion powers everything the sun gives us: light, heat, life itself. The energy created in the core does not rush outward. It takes hundreds of thousands of years to slowly work its way through dense layers of plasma. Once it finally escapes the surface, it crosses the distance to Earth in just over 8 minutes. From the outside, the sun appears steady and serene, but at its heart, it is fierce beyond imagination. Uranus carries rings of its own, not bright like Saturn, but subtle and dark. 13 known rings, made of tiny particles of rock and ice. These rings follow Uranus's extreme tilt. Because the planet lies almost on its side, the rings appear nearly vertical when viewed from certain angles. Some are narrow and sharply defined, likely shaped and maintained by small shepherd moons. They went unnoticed until 1977, when they briefly blocked the light of a distant star. Quiet bands, shadowy circles, encircling a sideways world. All of this exists inside a larger boundary. The sun constantly releases a stream of charged particles known as the solar wind. As it flows outward, it inflates a vast magnetic bubble around the solar system. This bubble is called the heliosphere. It surrounds the planets, comets, and distant objects, shielding them from much of the galaxy's radiation. Its shape shifts with solar activity and the pressure of interstellar space. At its edge lies the heliopause, where the sun's energetic influence fades. As the sun moves through the Milky Way, the heliosphere travels with it, a moving shelter, protecting everything inside as we drift through changing regions of space. Even Mercury played a role in reshaping our understanding of the universe. For centuries, astronomers noticed that Mercury's orbit behaved strangely. Its perihelion, the point where it comes closest to the sun, slowly shifted over time, more than classical physics could explain. In 1915, Albert Einstein's theory of general relativity offered the answer. According to relativity, massive objects like the sun warp the fabric of space-time itself. Planets do not simply orbit in straight paths. They follow curves shaped by gravity's influence on space. Mercury's subtle drift became one of the first confirmations of this idea. A small planet tracing a path that revealed a deeper truth about how the universe works. Ashajida metni yain biljalari kor erak, tamimen erskun, insan yazami hisiverin, sleep friendly, yavash vi hike, akishli bur, dil yeniden yazdam. Nighttime science, anlatimula, iam ludur. That small, steady shift in Mercury's orbit matched Einstein's predictions with remarkable precision. It became one of the first experimental confirmations of his theory of general relativity. a quiet victory for mathematics and observation, a subtle detail in the motion of a scorched, rocky world that helped change how we understand gravity itself. Closer to home, the moon is always at work. The gentle rise and fall of Earth's oceans are shaped largely by the moon's gravity. As it pulls on our planet, it creates bulges in the oceans, one facing the moon and another on the opposite side. As Earth turns, these bulges move across the globe, bringing high tides and low tides in a steady rhythm. The sun plays a role too. When the sun and moon align, their combined pull creates stronger spring tides. When they stand at right angles, tides weaken into neap tides. These tidal forces reach beyond the water. They subtly flex Earth's crust, and over vast stretches of time, even slow the planet's rotation. The moon never speaks, but it keeps the oceans in motion. Far beyond Neptune, mysteries remain. Astronomers have noticed that some distant objects in the Kuiper belt follow unusual, clustered paths, long, stretched orbits that don't quite make sense based on the gravity of known planets. One possible explanation is the presence of an unseen world, sometimes called Planet 9. If it exists, it would be several times the mass of Earth, orbiting far beyond Pluto, taking thousands of years to circle the sun once. So far, no direct observation has confirmed it, but the search continues, and if such a planet is found, it would reshape our understanding of the solar system's outer reaches. Among Jupiter's many moons, Callisto appears calm. Its surface is ancient and heavily cratered, showing little sign of recent geological change. Yet beneath that frozen shell, scientists suspect something more dynamic may exist. Data from past spacecraft hinted at a conductive layer below the surface, consistent with a salty subsurface ocean, kept liquid by internal heat and energy left over from formation. If confirmed, Callisto would join Europa and Ganymede as another hidden ocean world, less dramatic, less visible, but quietly holding the ingredients life might need, sealed beneath ice and time. Venus offers a different kind of surprise. Although Mercury orbits closest to the sun, Venus is the hottest planet of all. Its surface temperatures climb above 460 degrees Celsius, hot enough to melt lead. The reason lies in its atmosphere, thick, dense, made mostly of carbon dioxide. This blanket traps heat through an intense, runaway greenhouse effect. Sunlight enters, but warmth struggles to escape. Even though Venus reflects much of the incoming light, the heat remains locked in. Mercury, by contrast, has almost no atmosphere. It heats up quickly in sunlight, but just as quickly cools in darkness. Venus's extreme heat isn't about distance alone. It's about atmosphere and the power of trapped radiation. And finally, there are Saturn's rings. They may look like solid bands wrapped around the planet, but they are anything but solid. rings are made of countless individual pieces, mostly water ice. Some are tiny grains, others are chunks as large as houses. Together, they form an incredibly thin, flat disk, held in place by Saturn's gravity and shaped by nearby moons. The ice reflects sunlight efficiently, giving the rings their brilliant glow. From afar, they shine like something permanent. Up close, they are fragile, a vast collection of icy fragments, drifting together in quiet balance. Ashjada metni yain biljellary kor erak, Erskun, insan yazami hisivaran, sleep friendly, Yavash vi hike, akishli burr, dil yeniden yastim. Nighttime Science Tonala by Rebir Iam Ludur. Within Saturn's rings, nothing is truly still. Narrow gaps open between bands of ice. Wave patterns ripple outward. Thin ringlets curve and twist, shaped by gravitational resonances with nearby moons. These rings are not frozen in time. They are dynamic structures, constantly shifting, sculpted ice caught in motion, slowly rearranging itself as gravity whispers instructions. In the space between Mars and Jupiter, one object stands apart. Ceres is both an asteroid and a dwarf planet, the largest body in the asteroid belt, so massive that gravity has pulled it into a nearly perfect sphere. Discovered in 1801, Ceres is unlike its smaller neighbors. Beneath its surface, scientists suspect there may be a layer of briny water or muddy slush. When NASA's Dawn spacecraft visited, it revealed mysterious bright spots scattered across the surface. These glowing patches turned out to be salt deposits, likely left behind as water once rose, then slowly evaporated. Ceres is a hybrid world, not quite a planet, not just an asteroid, a quiet record of the raw ingredients that once built worlds. Mars wears its history on its surface. Its familiar red color comes from iron oxide. Rust over billions of years. Iron-rich dust reacted with the thin Martian atmosphere, coating the planet in a fine layer of oxidized material. That dust is everywhere. It colors the sky during storms and settles across plains, craters, and valleys. Up close, Mars is not entirely red. Dark basaltic regions break through the dust. White polar ice caps brighten the extremes. But from afar, the red dominates, a distant signal of oxidation on a cold, desert world. The sun, too, shows marks of change. Across its bright surface, darker patches appear from time to time. These are sunspots. They are not cold, but cooler than the surrounding regions, areas where intense magnetic fields suppress the outward flow of heat. Some sunspots grow larger than Earth itself. They often appear in pairs or clusters, shifting and evolving over days or weeks. Their numbers rise and fall in an 11-year cycle, peaking as the sun approaches solar maximum. Even then, they remain incredibly hot, thousands of degrees. They look dark only by contrast. Magnetic scars tracing the sun's restless interior. Uranus entered human awareness quietly. Unlike the planets known since ancient times, Uranus was not recognized until 1781. Astronomer William Herschel first spotted it through a telescope. Unsure whether it was a star or a comet, careful observation revealed its slow planetary motion. A new world, Uranus became the first planet discovered in the modern era, extending the boundaries of the known solar system. Its discovery marked a turning point, from naked-eye skis to instrument-guided exploration. Since then, Uranus has continued to surprise. Its extreme tilt, its faint rings, its icy moons, a planet that quietly rewrote the map of the night sky. All of this began long ago. The solar system is about 4.6 billion years old. Scientists know this by studying ancient meteorites, radioactive elements, and the oldest rocks found on Earth and the Moon. It began as a vast cloud of gas and dust, a solar nebula. Gravity pulled this cloud inward, forming the sun at its center. The remaining material slowly gathered, colliding and clumping together to create planets, moons, asteroids, and comets. It was a chaotic beginning. Violent collisions, shifting orbits, long, slow cooling. The worlds we see today are the survivors of that era, shaped by time, marked by motion, and among the asteroids, some carry deeper complexity. Vesta, for example, shows a layered internal structure, much like a small planet, a differentiated body. Another reminder that the line between asteroid and planet is thinner than it seems. Ashajida metniyin bilgelari korerak, Erskun, insan yazami hisiverin, sleep-friendly, Yavash vi hike, akishli bur, dil yeniden yazdam. Nighttime science, Tanu Koran muster. Vesta is more than a simple rock drifting through space. As the second largest object in the asteroid belt, it is considered a protoplanet, a world that began forming like a planet, but never fully became one. Beneath its surface lies structure, a mantle, and a dense metallic core. This layered interior means Vesta once held enough heat to melt and separate into distinct layers, a process known as planetary differentiation, the same process that shaped Earth and other rocky planets. At its south pole, the enormous Resilvia crater tells a violent story. A colossal impact likely tore away surface material, exposing deeper layers from within. Today, Vesta remains frozen in time, a planetary building block, a fossil from an era when worlds were still deciding what they would become. The moon, too, holds quiet motion, though it often appears calm and unchanging. The moon occasionally trembles. These moonquakes are subtle, but real. Some are caused by tidal forces, as Earth's gravity gently squeezes the moon. Others come from temperature changes, as the surface expands and contracts between lunar day and night. A few are triggered by meteoroid impacts, There are also deep moonquakes, originating far below the surface. These can last for nearly an hour, much longer than most earthquakes on Earth. They were first detected by instruments left behind during the Apollo missions. Even without tectonic plates, the moon reveals an interior that is not entirely still. A solid world with a quiet, pulsing heart. Triton's story is written in reverse. Neptune's largest moon follows a retrograde orbit, moving opposite the planet's rotation. This unusual path strongly suggests Triton did not form alongside Neptune. Instead, it was likely captured from the Kuiper belt long ago. That capture may have been violent, disrupting Neptune's original moons and twisting Triton's interior. The resulting tidal heating may still shape the moon today. Triton shows signs of active geology, including geysers that spray nitrogen into space. It has a thin atmosphere and a frozen surface patterned with strange, melon-like textures. Triton is both an ancient relic and a reshaped survivor, a moon adopted through force. Neptune itself hosts a quiet family. At least 14 moons orbit the distant planet, ranging from large and complex to small and irregular. Triton dominates the system by mass, but others, like Proteus, Naiad, and Larissa, trace varied and eccentric paths. Some of these moons were likely captured from the Kuiper belt. Others may have formed from debris left behind by collisions. Most are icy and dark, reflecting little sunlight. Together, their orbits offer clues to Neptune's turbulent history and the migrations that shaped the outer solar system. A scattered family, circling a planet at the edge of the sun's reach. Closer to home, one spacecraft dares to approach the sun itself. Launched in 2018, NASA's Parker Solar Probe became the first mission to fly directly into the sun's outer atmosphere. Known as the corona, it travels faster than any spacecraft ever built and withstands temperatures exceeding 1,000 degrees Celsius. A carbon composite heat shield protects it as it dips closer with each orbit. There, it measures the solar wind, magnetic fields, and energetic particles up close. Its mission is to answer long-standing questions. Why is the corona hotter than the sun's surface? How are solar flares accelerated to such extreme energies? In a way, Parker is not just observing the sun. It is moving through it, and some pieces of Mars have already reached us. Scattered across Earth's surface are meteorites that originated on the red planet, blasted free by ancient impacts. They traveled through space for millions of years before falling here. Small stones, silent travelers, carrying chemical fingerprints of another world. Quiet reminders that the solar system is not sealed. It is connected. Ashjida Metni Yain Bilgelari Korerak, Erskun, Insan Yazami Hisivaran, Sleep Friendly, Yavash Tempeluvi Hike, Akishli Bur, Dil Yeniden Yastim. Ernseki Nighttime Science, Burlum Laurel Tun, v riddim tamamen iam ludur. Mars, millionlarka kilometer, uzekta alabilir. Ama ondan kapan parseller, saktan buraya ulaştı. Dünyada bulunan bazı meteorlar, aslinda Mars'tan geldi. Bu kayalar, kizil gezegenin yüzeyin, sarpan guslu darbeler yüzeye fırladı. Sonra yüzen, sessiz bir yolculuğa çıktılar. Ve en sonunda dünyanın atmosferin gördüler. Bilim insanları bu taşları kimyasal imzalarından tanıyor. Mars yüzeyinden elinin veriler karşılaştırıldığında bir eşleşmeler ortaya çıkıyor. Bazılarının isinde Mars atmosferin 8 minisik gaz kabarcıkları var. Bazıları ise sayılı şekillenmiş mineraller taşıyor. Bunlar yalnızca taş değil. Başka bir dünyanın dağrudan örnekleri. Doga terrifinden biz gönderilmiş mesajlar. Yüze ersleri bunu yapmadan sak ernst. Güneş ise şaşırtıcı derecede sayed. Kudülsinin yaklaşık %70'i hidrojenden oluşuyor. Büyük kısmının geri kalanı helium. Bu iki hafif element Güneşin temelini oluşturuyor. Çekirdek, aşırı sıcaklık ve basınç altında hidrojen atomları birleşerek heliuma dönüşüyor. Bu sores nükleer füzyon ve asıga sıkan enerji Güneşin ışıcını ve ısısını dağıtıyor. Geri kalan küçük used oksijen, karbon, azot ve daha ağır elementler hepsi Güneşten ernst yaşamış yıldızların mirası. Ne kadar parlak ve güçlü görünse Güneş özünde basit. Yersekimyal bir araya gelmiş. İlkil gazlardan oluşan. Nükleer ateşil parlayan bir kura. Dünyadaki mevsimlerin sebebi ise küçük bir ecem. Gezegenimizin ekseni. Yörüncesen gör yaklaşık 20 usbusak deres ecek. Bu ecem olmasaydı. Bildicimiz mevsimler neredis. His yaşanmazdı. Bir yarım kura güneş dağru egildicend. Günler yüzer. Işık güçlenir. Yaz gelir. Diger yarım kura yüzüklaştıcında ise ışık azalir. Günler kizilir. Kiş başlar. Zaman isend bu. Ecem burası dicişti. Ayin vi diger. Gezegenlerin sekamayl. Ama hala hayatin ritmini. Belirlein. Sessiz mimarlardan biri almaya. Devam ediyor. Jupiter ise. Manyetik gukwail ernsikar. Anan manyetosferi. Güneş sistemindeki en büyük yapıdır. O kadar büyüktür ki. Görünür olsaydı, gökyüzünde güneşten bayıl, büyük görünüyordu. Bu alan, Jupiter'in içindeki metalik hidrojen tabakasında oluşan elektrik akımlarıyla beslenir. Manyetik sizceler boyanka, hızlı hareket, eden yüklü parçacıklar, şiddetli radyasyon kuşakları, devasa kütüp ışıkları ve güçlü elektrik fırtınaları yaratır. Ayının volkanlarından fırlayan parçacıklar bayıl. Bu manyetik alanın isen yakalanır. Yakındaki aycıların yörüngeleri bayıl bundan etkilenir. Yüze arasları isen bu bırılç teleklidir. Bilim insanları isins eşsiz bir Laboratuvar, Jezigen Halkalari, Desanaldigi, Kadar, Kalasai, Almeabalir, Sadwanun, Jupiterin, Uranusun v Neptunun Halkalari, Gursamuz, Zamansis, Guranor, Ama Cosmic Earlsect, Ermulari Kisa Alabilir, Bu Halkalar, Parsalanmish Ijularden, Sarpish Malardin, Yidiyakalanmish, Buzlu, Kalin Tillarden Alushur, Samanla, Yursikimi, Manietic Etkulshamalar v Sarpishmalar, Devrajayarar, Maltsim Yavish, Jezajin Dogradusher, Gerslemler, Sadwanun Halkalaranin, Use Million Yilden Daha Gents, Alabil Sajini, Gersterir, V Burkas, Use Million Yil, Isend Tamimen, Kabelabalurler, Belki Deshu, Anda Gerduklarimiz, Bur Jezajan and Hayden Daki, Kisa Ama, Buyulaisai Buren, Iise Naradus His, Dejishmez, Rusger Yak, Yagmer Yak, Active Tectonic Hairketler Yak, Bu Houston Ayin Usi Million Larka, Hada Milliar Larka, Yil Boyunka Eini Kalir, Astronaut Larin Byraktigi, Ayak Islari Bile, Bein Lurs Nessel Boyunka, Silin Medin Durabilir, I Zamani Tutin Bur Arshiv Jibidir, Sasses, Duragan, Ama Jesmishi, Kusur Suska, Saklayan Bur Yuzi, Ashajida Metni Yain Biljelari Kor Erak, Erskun, Insan Yazami Hisivaran, Sleep Friendly, Yavesh V, Akisai Bur, Dil Yeniden Yazdam, Nighttime Science, Ritmi Kornmuster, Ayin Yuzi, Tamimen, Duragan de Gildir, Ama Dejishim, Burada Sak Yavishtir, Mikrom Toratalar V, Cosmic Radiation, Zamanla Ayin, Usaini Ashendirir, Busuras Yuze, Erishmasi Denir, Gerzel Zor Fark Edelir, Ama Millionlarka, Yil Boyunka, Edkasini Biriktirir, Antic Sarpish Malarin, Astigi, Kraterler, Hala, Manzareya Hakimdir, Herbiri, Gunesh, Systeminin, and Urkin, Durnam Larine, Uzanan Bur, Sarpishma Kadadir, I Yalniska Dunianin, En Yakin Kamshusu de Gildir, Aini Samanda, En Eskivi, En Sadik, Geologic, Arshiv Larinden Biradir, Bazi Buzlu Ijularin, Durinliklarind Is, Bambashka Bur, Itimal Sakli Alabilir, Europa V, Enceladus Jibai, Ijularin Kalin Buzz, Kabaklaranin Altanda, Sivi Okeanuslarin Sikek, Kaalik Sekerdekler Temas, Edigi Dushanuluir, Bu Temas Noctalarinda, Dunyadaki Okeanus, Tebenlarinda, Bulunin Lara Benzer, Hydrodermal Bakalar, Alushabalir, Dunyada Bubakalar, Gunesh Ishigi Almedin Bile, Yashami Destekler, Energila Rini, Kimiezel Tepkeimlerden Allerler, Isi Suvi Mineraler, Hepsi Bur Aridadir, Edger Benzer Yapaler Bu Ijularda Devarsa, Yashem, Isin Jerikin Temel Koshaler, Saglin Mish Alabilir, and Celadustin Fishkurin Plumlerd, Biologic Suresleral Ilish Kylandiralin, by Leshiklarin Bulin Masi, Bu Itamali, Daha de Ilgens Killier, Bu Gizli, Karenlik Okeanusler, Belki de Dunya Dishi Yashami, Aramek, Isin, En Yumut, Verisai Yurlerdir, Gunesh Ishigi, Ise Biz, Dushundugumustan Daha, Jes Ulashir, Sildanizi Isitin, Gurki Uzunu Iden Latin Ishik, Yalkuluguna, Gunishin, Sekerdegend Bachelor, Nuclear Fusion, Suracinda, Orteasikin Fatonler, Gunishin, Isinden Jesserkin Yagun Plasma, Isind de Falarka, Yern de Gistirir, Bu Yalkuluk, Usbeinlers Yil Sura, Ama Usai, Ulishtikten Sonra, Ishler Hislanir, Gunishten Dunia Olan Yaklashik, 150 million kilometerlik Mesav, Sades Sekis, Dakikaden Buras, Fazla Sured, Kat Edelir, Burgun Dagumunu, Isladigenist, Yeta Ergel Vakti, Gurkusun, Baktigenista, Gurdugunus She, Gunishin Sekis Dakika, Ernseki Haladir, Sak Yakin Bur, Jesmishten, Jelen Bur Guruntu, Europenin Buzlu Yuzi, Desandigimis, Kadar Sabit, Almeabalir, Ayin Yuzi, Satlekler, Ku Sisdeller V Karmashik, Arezel Uruludur, Budi Senler, Buzz Kabaganan Herkit, Edier, Alabil Sajini, Dushandurir, Kirilan Kayan, Hadadalin Buzzlevalari, Edger Bu Dogrisa, Europa Dunya, Dishinda Levha Benzeri, Herketler, Gersterin Tek, Gurksismi Alabilir, Bu Herkit, Uzel Altaki Akianis, Ersinda Bisin, Alishvarashini, Mumkun Killarak, Yashanabalurligi, Ardarabalir, Tumbu Surasin Idasaiguku, Jupiterin Guslu Sekamidir, Surekli Geralin V Sikishin, Bur Isyapi, Europa Donmush, Bur Dunya Alabilir, Ama Kessenlikal, Duragan de Gildir, Saduin Is, Bambashka Bur, Hafaflik Tashir, Teoric Olarak, Anu Dev Bur Cosmic Kuvit, Koyabilsidin is, Userde, Sunku Sadwinun Ortalama, Yaganlugu, Sudan Dahadushuktur, Isibash Oldugu Isin Dejil, Buyuk Earlsud Hydrogen V, Heliumden Alishtugu Isin, Hakmi Dunianin Kindin, Yeti Use Kat Fazla, Ama Kudalsi Sades, Doxen Besh Kat, Dahabuyuk, Bu Dushuk Yaganluk, Hisli Dernushal Burlishtigend, Jezageni, Cutaplarden Basic, Ekvatorden Shishkin Hail Getirir, Yersikimi V, Herkatin Yumushaksa, Shekelender Digi, Burgaz Davy, Gunesh Ise Bazin, Sakinlagini Bazar, Gunesh Patlamalari, Usidin Anadin Furlayan Guslu Energy, Boshal Malaridir, Genelical Gunesh, Lekalaral Ilishkiladir, Bu Patlamalar, Ex Ishinlari V Mortesi, Ishinim Dahil Almek, Uzer Yagan Radiasin Yayar, Edger Duniaya Dagru Yernalers, Ust Atmospheri et Kalibalir, GPS Systemlari Axiabalir, Radio Altishimi Bazulabilir, Ijular et Kalnebalir, Nader Ama Guslu Alilarda, Manietic Furtinaler, Electric Shebikelarine Bile, Zerar Variabilir, Gunesh Sagu Zaman Sakin Guranur, Ama Zaman Salmon, Technologimize, Ulashakik, Kadar, Guslu Bur, Shekelda, Haderlader Kendini, Ashajida Metni Yain Biljelari Kor Erak, Erskun, Insan Yazami Hisivaran, Sleep Friendly, Yavash V Hike, Akishli Bur, Dil Yeniden Yastim, Nighttime Science, Anlatimila, Iam Ludur, Dunianin, Manietic, Alani, Busy Korer, Ama Gunesh Patlamalari, Biz Ernamli Bur, Jursigi Haderladir, Gunesh Sabit Bur Ampol de Gildir, O Yashian Dejishan, Salmon Erfkalenen Bur Yildistir, Basin Energicini Dalguller, Hayland Usea Gurnderir, Bu Dalguller Tum Gunish Systemi, Boyanka Hisidilir, Bu Herkit Liligin, Isla Rini, Gurkiusund Gurabiliriz, Cutup Ishiklari, Yani Oreller, Dunianin Manietic Alani, Isle Gunishten, Jelen Uklu Parsisiklarin, Bulish Masila Alushur, Yeshel, Kermazi V, More Pertler Jibai, Gurkiusund Dalgalanerler, Bu Ishikler, Gunishin Yaklashik, Unbur Yilik Derngusual Baglantilidir, Gunish Maximum Dernamindikin, Gunish Lekalari V Patlamaller Arter, Daha Fazla Parsisik Dunyaya Ulashir, Oreller Daha Parlek, Daha Hirkitli Aller, Minimum Dernimt, Ise Gurkusu Daha Sakindir, Daha Sesses, Gunishin Maniatic, Nabzi, Usea Yaelir, Biz Debu Ritmi, Gessanin Isend Parlayan Ishiklarla Gurus, Use Havasanin, Gurkuzun Atigi Umushak, Fursa, Darbalari Jibai, Kyraklu Yildisler de Gunishin, Gurunmiz, Etkasini Tashir, Bur Kyraklu Yildiz, Gunish, Yaklish de Jinda, Buzlu Yuzi, Surzulmai Bashler, Gazvi Taz, Asigasikar, Parlek Bur Kyrak Alushir, Ama Bu Kyrak, Beklidijimiz Jibai, Arkasinda Suruklanmiz, Herzaman Gunishten, Uzagi Gersterir, Yildiz Hangi Yurn Geider Skitsen, Bana Nedani, Gunesh Rusgari V Ishanim Basin Sidir, Bu Kavitler Madi, Dishari Dagru Eiter, Sanasta Iki Kyrak Alushir, Biri Kevisli, Tazden Alushin Kyrak, Didri Isa Duz, Mavimzi, Ian Larden Alushin Kyrak, Bu Parlak Isler, Gunesh, Ishijinin Uzedaki Gurunmiz, Dokanash Larini Sizer, Bazi Ijuler Ise, Shidedal Dogdu, Dunyanin Ayanin, Yaklashik Dirt Milyar Yil Ernst, Jursikleshin, Devbur Sarpishma, Sanuku Alishtugu, Dushanulir, Jens Dunya Isle Mars, Buyuklugund Bur Sisim Sarpishti, Ortea Sasalan, Mad Urunjt to Plandi, V.I. Shekalendi, Benzer Bur Kirkanen, Plutonon, Ijusu Karen Isin de Jesserli, Alabilsegi, Dushanuluyer, Bu Tuor Dagamler, Hli V. Yikasidir, Amatum, Ijuler Burel Alishmadi, Basilari Dish, Jezagenlerd Oldugu Jibai, Yersikimial Yakalandi, Sesses Yavashta, Ijularin Kirkenlari Seshet Lidir, Bu Seshet Lilik, Gunesh, Systeminin Urken Durnam Larindeki, Chaosu V. Yaratisaligi Yansatir, V. O. Urken Durnam Lurden Bur, Message, Hala Yalkulukta, Voyager 1, 1977, Yelinda Furlatildi, Bugun, Dunyadan En Yuzak, Insan Yapami Nesnadir, Arctic Yildiz Lararasi, Uzeda Eilerlier, Yeninda Bur, Alton Plak Tashir, Bur Gramoffen Diski, Buplakta, Dunyadan Seslervar, Dalgalarin Uggletusu, Kush Sesleri, Kakeheller, Farkli Dillard Selamler, Dunyanan Dirt Bur, Yananden Musikler, Carl Sagan, Litterligendeki, Bur Ekip, Terrafinden, Hazerlandi, Belki Bur Goon, Bashka Bur Seka, Terrafinden Bulener de, Bur Shaishe Konmush, Mesed Jibai, Galaxy Birakelmish, Sesses Bur Selam, Salyuk Mavi Noctimisden, Visun Olarak, Dunya Aslinda Yalnis de Jill, Uranjasini Bashka, Kusuk Sisimlural Palashir, Banlara Esh Urunjeli, Asteroidaler Denier, Bu Sisimler Dunianen, Itrafinda Dalanmaz, Ama Gunesh, Itrafindaki Yalkulaklarinda, Dunianen Urunjasin Yakin Kalerler, Bezalari, Dunianen Ernund, Yida Arkasinda Bulanen Kararli, Noctalarda Suzuluar, Banlara Truva, Asteroidal Redenier, Bezalari Ise, Etnali Shekland Yaller Isler, Yaklashir Ama, Aslas Sarpishmaz, Bu Cosmic Yal, Arkadishlari, Genelical Jessisidir, Beinlurs Yil Boyanka Yakalanir, Sonra Serbist Kalerler, Siplak Gurzel Gurun Mezeler, Ama Ordederler, Bismal Berlicht, Gunesh Itrafindaki, Yusan Yalkulugu Palashin, Sesses Jesjanler, Ashjida Metni Yain Biljelleri Korerak, Tamimen Erskun, Insan Yazami Hisivaran, Sleep Friendly, Yavash V Hike, Akishli Burr, Dil Yeniden Yazdam, Nighttime Science Tonala by Rebir Iam Ludir, Neptune, Yusan Surafark, Edelmedin, Gurki Uzund Dalashti, Rismi Olarak, 1846, Dekesh Fidelmedin Ernst, Bazi, Gurk Balimsiler, Anu Gurmush Alabilir, Amane, Bacticlarini Bilmedin, Neptune Sok, Yavash Herkit Eder, V Olduxa Cernuktuar, Bu Houston Salmon, Salmon Sabbat, Bur Yildiz Sanildi, Bazin de Uranusun Bashka, Bur Gurslimi, Oldugu Dushanoldu, Hada Galileo Galileanin, 1612, Yelinda Teleskabala, Neptunu Fark Etmish Alabilsegi, Dushanuluyur, Not Larinda, Anubur Yildiz Olarak, Isharetaldi, Jazijan, Oldugunu Bilmedin, Neptunan Jursek Kimligi, Ankak, Uranusun Uranjasindeki, Kusuk Duzen Sislakalar Fark, Edeldigend Orteasikti, Matematixeller Bu Sapmalari Asaklemek, Isin Gurun Main Bur, Jezigenin Varlagini, Erngerdu, V Teleskopler Tam, De Hesaplanen Ur, Several Digend, Neptune Oradati, Gurkuzu Herkit, Eden Ishaklarla Daliken, Neptune Uzialer Boyanka, Gurs, Ernund, Ama, Gisli Kaldi, Gunesh, Systeminin Saniri de Sanaldigi, Kadar Net de Gildir, Guneshin Yursakimi, Plutonun Sok Erdasine Uzinir, Uit Bulutindaki, Uzak Kyraklu Yildislari, V Buzlu Sisimlari, Hala Kendin Bagley Tudor, Ama Bilim Insanlari, Gunesh Systeminin Kenari, Endan Sirs Edigind, Sagu Zaman Bashka, Bur Saniri Castidir, Heliosferin Sanunu, Burasi, Gunishtan Sikin Gunesh, Rusgarinin Yildislarasi, Ortemla Karshalashtigi Noctadir, Heliopos Adi Verilin Businurda, Gunishin Manietic Etkasi, V Parsasik Akishi, Sona Urur, Yursakimi Devam Eder, Ama Energy Orada Durer, Bu Sinir, Keskin Bur Sizgi de Gildir, Daha Sok Bur Jesishtir, Varlachin de Jill, Etkanin da Jishtigi Bur Eshik, Jezigen Larin Atmospherelary, Desamanla Kasak Verrier, En Kalin atmosphereler bile, sansas, de gildir. Hydrogen v helium, gibai hafif gasler. Yavash, jezagenlerin, sekaminden kirchulup, usea caesar. Bu sures atmospheric, cassish denir. Kusuk jezagenlerd daha, belergendir. Mars v Mercury gibai. Venust ise magnetic koroma exekligi. Gunesh rusgarinen ust atmospheri ashendermacina is inverti. Dunya bile, her yil beinlers tun hydrogeny kabder. Bu kaib genelical fark, edilmes. Sunku surekli yenalnir. Amabu, jezagenleral bashluk, erisindaki sesses, bur alish verishtir. Hisdermian, yavash bur sizenti. Bazi igeler is, helkalarden dogmush alabilir. Nassel kai helkaler, semanla dagelabilir. Eini shekelda. Basin burleship igeler alishterabilirler. Sadwin seversind. Bazi kusuk, igelerin bashlingista helka. Maltsemessenden alishmush, alabilsegi, dushanuluyer. Urzulikal raj, sinirinin dishinda. Yersikiminin arctic, maddi, parsalamic. Yerin bur area, gether bildigi, burljed. Panvi daphnis, gibai kusuk igeler. Hala halkalerin, isind dalinir. V mudamelin hala, mad toplamactidurler. Bu minik igeler. Halkalerin sesses, hakel turishlaradir. Yersikimleril, bashlakler asar. Dalguller yaratir. Buzlu bent lari, shekelenderir. Visak uzekta. Bur message hala yoldadir. Voyager 1. Furlatil masinin uzerinden 45. Yilden fazla salmon jesmasine. Ragman hala. Very gernderir. Arctic yildislerasi ortemda. Duniaden milyar larka. Kilometer uzekta. Sihislari cosmic ishinlari. Magnetic alinlari. V yildisler ersindaki. Plasminin. Yaganlugunu earlsweer. Energisi senili. Bu used in bazi. Systemler. Yavash capitalier. Ama hala salishir. Kusuk bur nuclear goose canagila. V derin. Use agi uzerinden. Gernder digi. Hersinilin dunyaya ulishmasi. Yemi saadi. Ashken suruyer. Insanlagin. En uzak. Fisiltilarinden biribu. Vitumbu yalkulakler. Dahabuyuk bur herkatin parsasi. Gunesh systemi. Samanialanan itrafinda bur tirunu yaklashik. 225 million yilda tamamler. Bu surai cosmic yildenir. Dinazorler bu tiran. Bashinda ordia sikti. Viyak oldeclarinda. Gunesh systemi hala ilk tirunu bile by termamishti. Biz bu uzan galactic yalkulugun. Sak kisa bur ananda burideas. Sesses dernen bur systemin isind. Yildisler erisinda. Suruklenin bur yuva. Elbet. Ashajida metni bildulari korerak. Tamimen erskun. Insan yazami hisiverin. Sleep friendly. Yavish v umushak bur kapanish anlatimila. Yeniden yazdum. Nighttime science. Isin final burlumu olarak. Akisa shekel de baglanir. Jezageneler gunishin. Itrafinda dernerkin. Gunesh de yerend dermaz. O diyal alir. Tum gunesh systemi. Samanialo galaxisinin, merkezinin, itrafinda sesses derner. Bu Budev Yalkulugun Tek Burturu. Yaklashik Iki, use Yemi Besh Il Iki, use Eli Million Yil Sura. Buna Basin Cosmic Bur, Yil Denir. Bu Sura Boyanka. Gunesh Systemi, Galaxinin Farkli Burl Jillarinden Jesser. Yildislarin, Dogjugu Kolarin Yakininden. Sarek Gaz Vitaz, Bulatlarinin Issenden. Sesses, Karenlik Boschlaklarden. Buherkit, Salmon Kyraklu Yildislarin, Yernunu Etkalibalir. Sakdaha Yuzan Earlsiklerdis. Duniadaki Iklim Uzerind Bile, Isler Byrakmish Alabilir. Biz Uzeda Sabbat Digilis. Yavish Bur Spiral Isind Eiler Lioras. Galaxinin Bur Kaluna Tutenmush Halda. Cosmic Bur Atlikarinka Jibai Durnarek. V Burels Gunesh Systemi Isindeki Bu Sesses Yalkulugumas. Yavashsa Son Arayer. Guneshal Kavralmush Is Dunyalarden. Karenlikta Fisseldayan Buzlu Ijulara Kadar. Yerunjelarden. Furtinalarden V. Girljelarden Jestik. Bayarer. Ikulu Biljelar Eshlajind. Edger Gerslerin Agerlashtiasa. Butamimin Normal. Dushuncelarinin Arkasinda. Kalan Sun Yildiz Ishiklari. Diyavashsa Cernsun. Nephasin Sini Naziks. Dinlanamai Tashasin. Keshvidelsek Dahasak Shavar. Ama Shimdalik Yeterins Yal Alden. Sak Uzaga Gittin. Evrin Sabaha Kadar Beklibilir. Bu Samani Benimel Palishtigen. Isin Teshakur Ederem. Sesses Yildislarin Altenda. Hike Devam Edir. Idi Ikiller. Tatli Ruyeller. Crescent Moon.